Welcome to Coin Fabric's Learning to Scout series on Substrate, Polkadot's Rust framework for building modular and extensible blockchains. In this video, we'll explore an issue known as unsafe block. The use of unsafe blocks in Rust is generally discouraged due to the potential risks it poses to the safety and reliability of the code. Rust's primary appeal lies in its ability to provide memory safety guarantees, which are enforced through its ownership and type systems. When you enter an unsafe block, you're bypassing these safety checks. These blocks require the programmer to manually ensure that memory is correctly managed and accessed, which is prone to human error and can be challenging even for experienced developers. Therefore, unsafe blocks should only be used when absolutely necessary and when the safety of the operations within can be assured. Here is an example where this issue appears. This function includes a raw pointer that points to the memory address of input. Then, the variable value dereferences the raw pointer. This directly accesses the memory location and calls the rotate left method on the value stored at that location. If the pointer is invalid or points to an unexpected memory location, dereferencing it can cause undefined behavior, such as crashes, data corruption, or security issues. Let's run Scout on this code. We navigate to the palette directory and run cargo scout audit. The warning related to unsafe block appears, highlighting the issue. By removing the raw pointer, we solve the issue associated with dereferencing memory in an unsafe way. Rust's type safety checks ensure memory is accessed correctly, preventing the potential issues associated with the usage of unsafe blocks. Now, when we reanalyze our corrected code with Scout, it no longer detects the issue, confirming our fix. Thanks for watching. Check out the links in the description to learn more about Scout, and don't forget to like and subscribe for more tutorials like this one.